The Gerald R. Ford-class aircraft carrier represents a fundamental shift in maritime force projection, prioritizing system-level efficiency over mere physical displacement. Valued at over $13 billion, this floating fortress is engineered to dominate contested waters through sheer technological superiority and rapid sortie generation. While visually mirroring the legendary Nimitz-class hulls, the internal architecture of the Ford has been radically reconfigured to optimize modern combat logistics. The structural profile features 25 integrated decks, spanning from the reinforced lower hull to the apex of the redesigned stealth superstructure. This vertical expansion drastically increases internal volume, providing a crucial logistical advantage over the 18-deck configuration of older legacy aviation cruisers. Such architectural maximization allows the Ford to sustain an embarked air wing of nearly 90 advanced combat aircraft and rotary assault assets. This presents a decisive 30 aircraft superiority over standard Nimitz loadouts, fundamentally altering the calculus of naval strike operations in any theater. The core of this increased capacity lies in the vastly expanded hangar bay, functioning as the primary maintenance and mechanical staging artery. Spanning 2/3 of the total hull length, this heavily armored internal cavity isolates sensitive aviation assets from the corrosive maritime environment. Above this vital maintenance space sits a sprawling flight deck, encompassing 5 acres of reinforced steel engineered for continuous global combat operations. This immense operational surface measures approximately equivalent to 4 professional football fields, cementing its status as the largest mobile structure ever constructed. The island superstructure was intentionally minimized and shifted 41 feet further aft, drastically expanding the usable real estate for immediate aircraft maneuvering. This deliberate spatial optimization streamlines the critical refuel and rearm sequences, directly translating to a projected 33% increase in daily sortie rates. To manage this staggering volume of machinery, the Ford utilizes 3 ultra-wide, high-speed aircraft elevators instead of the traditional 4 scattered lifts. The forward-starboard elevator rapidly cycles strike fighters from the lower maintenance bays directly to the primary bow launch catapult engagement zones. Simultaneously, the centralized midship elevator functions as the primary logistical conduit, effectively neutralizing the hangar bottlenecks that crippled previous carrier generations. The aft elevator provides dedicated access for post-recovery maintenance, efficiently clearing the landing strip to maintain the relentless pace of combat operations. But the most radical departure from legacy architecture is the complete elimination of archaic, maintenance-heavy steam piping for aircraft launch and acceleration mechanisms. The revolutionary Electromagnetic Aircraft Launch System, or EMALS, officially replaces volatile pressurized steam with hyper-efficient, software-controlled linear synchronous electric induction motors. Powered by the ship's massive localized grid, multi-megawatt kinetic energy storage systems hoard direct current until the precise mathematical millisecond of launch. Upon command, advanced power inverters instantaneously convert this stored direct current into a highly tailored, explosive pulse of high-frequency alternating current. This customized electrical surge floods a linear motor track embedded beneath the deck, generating a cascading magnetic field of immense kinetic force. The aircraft's reinforced nose gear locks into a hardened, electromagnetically driven shuttle that precisely rides this invisible, frictionless wave of magnetic propulsion. Unlike the violent, skeletal stressing shock of a steam catapult, EMALS utilizes programmed digital algorithms to deliver a perfectly smooth, calculated acceleration curve. This software-defined acceleration minimizes catastrophic airframe fatigue, ultimately extending the operational lifespan of the entire multi-billion-dollar naval aviation combat strike fleet. Reaching terminal takeoff velocities exceeding 150 miles per hour, the shuttle seamlessly decouples, allowing the deadly payload to achieve immediate lift. Following decoupling, the localized electromagnetic field instantly reverses its polarity, silently decelerating the massive shuttle and resetting it for the next combat launch. This precise control allows the system to launch an unprecedented variety of payloads, from heavy strike fighters to fragile, lightweight autonomous surveillance drones. Operating at maximum designed efficiency, this synchronized mechanical ballet permits the elite deck crew to launch up to 4 fully armed aircraft every 60 seconds. To shield the deck crew from blistering 1,000-degree exhaust plumes, massive jet blast deflectors are hydraulically raised to a strict 45-degree angle. In stark contrast to foreign carriers relying on primitive ski jump ramps, the Ford retains the superior flat-deck catapult configuration for maximum payload capacity. Recovery operations rely on the advanced arresting gear system, replacing legacy hydraulic rams with water twisters and massive electric rotary induction motors. 4 highly tensioned steel cross-deck pendants lie precisely across the landing strip, waiting to violently capture the titanium tailhook of a returning fighter. Upon engagement, the software-controlled induction motors precisely manage the rapid deceleration, safely bleeding off the kinetic energy of a 20-ton aircraft in seconds. This localized command and control is managed from the primary flight control center, colloquially known by the naval aviation community as the Air Boss Station. Perched high within the stealth-optimized island, this pressurized nerve center provides unrestricted panoramic visibility over the chaotic, high-stakes combat flight deck environment. Directly beneath the Tactical Aviation Command lies the heavily armored navigation bridge, where the ship's captain dictates the vector of this nuclear-powered Leviathan. Plunging deep into the shielded interior reveals the Combat Direction Center, a decentralized command hub actively processing encrypted terabytes of active battlespace data. This armored bunker synthesizes telemetry from satellite uplinks, airborne early warning radar, and the carrier's own proprietary integrated phased array sensor systems. The Ford utilizes a dual-band radar system, an active electronically scanned array that simultaneously tracks high-altitude ballistics and sea-skimming autonomous cruise missiles. When hostile interceptors or autonomous drone swarms breach the outer defensive perimeter, automated threat evaluation algorithms instantly designate incoming priority targets for immediate destruction. These algorithms seamlessly network with the ship's localized point defense grid, ensuring absolute zero latency between target acquisition and lethal automated kinetic interception. To quickly supply these weapon systems, advanced weapons elevators utilize permanent magnetic synchronous motors instead of vulnerable mechanical cables and traditional steel pulleys. These dedicated electromagnetic lifts can seamlessly move 24,000 pounds of high-explosive ordnance at an astonishing vertical speed of 150 feet per minute. Deep within the armored lower hull, vast universal ordnance magazines store thousands of tons of smart munitions in reinforced, blast-mitigating compartmentalized storage bunkers. By actively segregating explosive combat logistics from general internal cargo, the naval architects fundamentally reduced the mathematical probability of a catastrophic secondary chain reaction. Sustaining continuous combat operations requires massive human capital, with a specialized operational crew of over 4,000 dedicated sailors and elite combat aviators on board. To minimize operational friction, the crew living quarters, mess halls, and expansive logistics bays are decentralized across multiple environmentally controlled interior lower decks. Automating countless legacy physical systems allowed naval engineers to drastically reduce the necessary crew complement by several hundred, saving billions in projected lifecycle operational costs. This floating military city functions entirely as a self-contained, sovereign territory capable of projecting absolute American air supremacy across any contested global oceanic battlespace. Maintaining the integrity of this sovereign platform requires a multi-layered defensive perimeter designed to neutralize saturation attacks from hypersonic missiles and autonomous swarms. The Gerald R. Ford class utilizes a highly integrated ship self-defense system, or SSDS, which synchronizes the vessel's diverse kinetic and electronic warfare suites. At the outermost layer of point defense is the RIM 162 Evolved Sea Sparrow Missile, or ESSM, designed to intercept highly maneuverable anti-ship cruise missiles. These missiles are housed in vertical or box launchers, capable of reaching supersonic speeds to engage threats before they enter the ship's visual horizon. Supplementing the ESSM is the RIM 116 Rolling Airframe Missile, which utilizes a dual-mode infrared and radio frequency seeker to track and destroy incoming projectiles. For close-in threats that breach these long-range barriers, the Ford deploys the Mk-15 Phalanx Close-In Weapon System, a self-contained radar and gun platform. This 20mm Gatling gun fires specialized tungsten armor-piercing rounds at a cyclic rate of 4,500 shots per minute, creating a localized wall of kinetic energy. The Ford's Phalanx units are specifically upgraded with high-resolution thermal sensors to better identify and track low-observable maritime drones and small boat threats. Protecting the flight deck further are heavy M2 50 caliber machine gun mounts, providing human-in-the-loop defense against asymmetrical close-range surface incursions. However, the Ford never operates in isolation. Its true survivability is derived from its position at the center of a carrier strike group. This system of systems typically includes a Ticonderoga-class guided missile cruiser, acting as the primary air defense commander for the entire fleet. Surrounding the carrier are multiple Arleigh Burke-class destroyers, equipped with the Aegis combat system to provide a robust multi-mission protective screen. These destroyers focus on anti-air and anti-submarine warfare, utilizing their SPY-1 or SPY-6 radar arrays to track hundreds of targets simultaneously across the horizon. To manage the threat from beneath the surface, the strike group is often shadowed by a Virginia-class nuclear-powered fast-attack submarine. This submerged asset provides a critical stealth advantage, hunting hostile submarines and surface vessels that attempt to bypass the surface-level sonar screen. Modern maritime logistics also include a dedicated supply vessel, ensuring the carrier and its escorts can remain on station for months without returning to port. The Carrier Air Wing, or CVW, functions as the primary offensive arm, extending the ship's reach across thousands of square miles of maritime territory. Dominance in the electromagnetic spectrum is maintained by the E-2D Advanced Hawkeye, an airborne early warning and control platform with a distinctive rotating radome. The Hawkeye acts as a high-altitude digital sentinel, detecting low-flying cruise missiles and enemy aircraft long before they are visible to shipborne sensors. Logistical sustainment is facilitated by the C-2A Greyhound, or the CMV, 2-2B Osprey, capable of delivering critical components and personnel from shore bases. Subsurface threats are actively managed by the MH-60R Seahawk helicopters, which deploy dipping sonar and sonobuoys to triangulate the position of enemy hulls. Once a target is identified, these helicopters can deploy Mk-54 lightweight torpedoes, which utilize active acoustic homing to pursue and neutralize the threat. This multi-layered, multi-domain architecture ensures the Ford class remains the most difficult target to localize and destroy in the history of naval warfare. Powering this entire massive enterprise are two Bechtel A-1B nuclear reactors, specifically designed to meet the ship's immense electrical demands. These reactors represent a massive technological leap over the A-4W reactors used in the Nimitz class, offering 3 times more electrical generation capacity. The A-1B design is significantly more compact and utilizes a simplified plumbing architecture, reducing the number of required valves, pumps, and maintenance personnel. Within each reactor core, controlled nuclear fission of highly enriched uranium generates intense thermal energy, raising the temperature of the primary coolant. This primary coolant transfers heat to a secondary water loop through steam generators, creating high-pressure, high-velocity dry steam. This steam is directed through massive main propulsion turbines, which convert thermal energy into the mechanical rotational force required to turn the ship's shafts. The Gerald R. Ford utilizes 4 massive bronze alloy propellers, each spanning over 20 feet in diameter and weighing approximately 30 tons. These propellers are engineered with precise blade geometry to minimize cavitation, ensuring high-speed efficiency while reducing the ship's acoustic signature. Beyond propulsion, the steam drives 8 massive General Electric turbine generators, creating a localized power grid capable of lighting a medium-sized city. This robust electrical architecture is critical for the EMALS and advanced arresting gear, which require massive instantaneous surges of power. Unlike legacy ships, the Ford class utilizes a zonal electrical distribution system, allowing for rapid rerouting of power if segments of the ship sustain damage. This redundancy ensures that even during heavy combat, critical sensors and weapon systems remain operational despite localized hull breaches. The ship's top speed is officially classified, but is widely estimated to exceed 35 knots, or approximately 64 kilometers per hour. At these speeds, the 100,000-ton vessel can outmaneuver many smaller surface threats, using its mass and inertia to maintain stability in high sea states. The A-1B reactors are designed to operate for 25 years before requiring a midlife refueling and complex overhaul of the core. This logistical endurance allows the Ford to operate globally for decades, projecting power without the need for frequent, vulnerable fuel replenishment at sea. To manage the extreme heat generated by these systems, the ship employs an advanced freshwater cooling system and massive condenser units. Seawater is pumped through these condensers to cool the steam back into liquid form, which is then recycled back into the steam generators. This closed-loop system ensures that the carrier maintains a constant supply of pure water for its boilers and the thousands of crew members on board. The ship's freshwater plants utilize reverse osmosis technology to produce over 400,000 gallons of potable water every single day. Every cubic centimeter of the ship is optimized, including the placement of engineering spaces to lower the ship's center of gravity and improve stability. Advanced 3D modeling and computer-aided design allowed engineers to simulate every pipe and wire before a single plate of steel was cut. This digital twin technology ensures that future upgrades to laser weapons or railguns can be integrated with minimal structural modification. The Ford class is not merely a replacement for the Nimitz. It is a foundational platform for the next 50 years of American naval dominance. Every system, from the electromagnetic catapults to the nuclear reactors, is built with a focus on increasing lethality while reducing long-term costs. In an era of shifting geopolitical alliances and emerging peer threats, the Ford class stands as the ultimate deterrent in the global maritime commons. The sheer physical presence of this vessel serves as a cold, calculated reminder of the industrial and technological might of the United States Navy. The mechanical heart of the Ford's lethality resides within its 11 advanced weapons elevators, moving munitions from deep magazines to the flight deck. Utilizing permanent magnet linear synchronous motors, these elevators eliminate the vulnerability of traditional cables, ensuring continuous operation even during high-intensity kinetic engagements. This electromagnetic lifting architecture allows for a total weight capacity of 24,000 pounds per lift, moving at twice the speed of legacy systems. By streamlining the movement of high-explosive ordnance, the Ford achieves a significantly faster pit stop for returning strike fighters during sustained air campaigns. Beyond physical munitions, the Ford class is a titan of information warfare, utilizing the dual-band radar to dominate the electromagnetic spectrum. This integrated radar suite combines X-band and S-band frequencies into a single, software-defined interface, providing unmatched resolution for tracking low observable aerial threats. In the modern age of drone warfare, the ship's ability to process and categorize thousands of data points per second is its primary survival mechanism. Small, fast-moving autonomous drone swarms represent a paradigm shift in maritime threats, requiring a defense that is both automated and computationally superior. The Ford's automated point defense systems are networked via the cooperative engagement capability, allowing the ship to fire based on data from distant destroyers. This network-centric warfare ensures that no single point of failure can blind the carrier strike group to incoming hypersonic or low-flying autonomous assets. To address the cost-per-kill ratio of expensive missiles against cheap drones, the Ford is designed with massive power margins for future laser integration. The A-1B reactors provide 60 kilowatts of excess power specifically reserved for directed energy weapons that can neutralize drone swarms at the speed of light. This future-proofing ensures that the vessel remains relevant in an era where kinetic projectiles are increasingly supplemented by high-energy laser and microwave emitters. Living within this 100,000-ton steel hull is a crew of 4,500 personnel, supported by a sophisticated internal logistical infrastructure. The ship's floating city status is maintained by massive galleys capable of serving 18,000 meals daily, ensuring peak operational readiness for the crew. Crew fatigue is a critical physical constraint. Therefore, the Ford features redesigned berthing areas with improved acoustic dampening to facilitate better sleep cycles. The ship's medical facility is effectively a full-scale trauma hospital, featuring 3 operating rooms, a pharmacy, and intensive care units for long-duration missions. Every internal deck is a miracle of spatial engineering, housing specialized workshops for the repair of F-135 jet engines and advanced avionics suites. This self-sufficiency is vital for blue water operations, where the carrier must function as its own primary shipyard and maintenance hub for months. The Gerald R. Ford's hull is designed with a 50-year service life, making it a permanent fixture in the strategic calculus of global superpowers. Critics often cite the $13 billion price tag, yet this figure represents the physical cost of absolute oceanic control and diplomatic leverage. The carrier serves as a mobile sovereign territory, allowing the United States to project force without the need for terrestrial basing rights in volatile regions. Its mere arrival in a contested theater provides a power narrative that can de-escalate conflicts through the threat of overwhelming kinetic response. The transition to electromagnetic launch systems and nuclear power is not just an upgrade, it is a total reimagining of naval power. While legacy carriers are constrained by the physical limits of steam and hydraulics, the Ford class is limited only by its software and electrical output. This shift allows for the integration of next-generation, 6th-generation fighters and high-autonomy wingman drones that have not yet been fully realized. As maritime contested zones become more lethal, the Ford's combination of stealth-optimized superstructure and high-output sensors provides a decisive tactical edge. The vessel's internal zonal electrical distribution system ensures that even catastrophic hull breaches do not result in a total shipboard power failure. Every bolt, circuit, and software line on the Gerald R. Ford is a calculated investment in the maintenance of the international maritime order. The carrier does not just participate in geopolitics. Its physical presence often dictates the boundaries of what is possible in international diplomacy. For the aviators on the deck, the EMALS system provides a safer, more reliable launch platform that reduces the physical strain on the human body. The advanced arresting gear allows for the safe recovery of aircraft with varying weights, from light reconnaissance drones to fully loaded heavy bombers. This versatility is the hallmark of the Ford class, providing a flexible response platform for a wide spectrum of military and humanitarian operations. The ship's massive freshwater production and storage capabilities also make it a primary asset for large-scale disaster relief in coastal populations. However, its primary purpose remains the cold, hard logic of deterrence and the systematic destruction of enemy air and sea assets. The Gerald R. Ford is the physical manifestation of the concept of overmatch, where every system is designed to be superior to any possible peer threat. In the high-stakes environment of the Indo-Pacific or the North Atlantic, the Ford functions as the ultimate arbiter of naval supremacy. Its nuclear propulsion ensures it can traverse the globe at 30+ knots without ever needing to stop for fossil fuel replenishment. This logistical freedom is the ultimate strategic advantage, allowing for rapid repositioning in response to evolving global crises. The Ford class is a masterclass in hard surface modeling and system-level engineering, representing the pinnacle of 21st century industrial capacity. As the first of 10 planned vessels, the CVN-78 is the vanguard of a new era that will define naval warfare for the next half-century. Its integration of robotics, electromagnetic propulsion, and high-density nuclear power creates a platform that is effectively a floating supercomputer. To observe the Ford in operation is to witness the convergence of physics, engineering, and geopolitical strategy in a single mobile asset. The complexity of its 25 decks is matched only by the complexity of the global missions it is designed to execute with cold precision. While drones and missiles evolve, the aircraft carrier remains the only platform capable of sustaining a long-range air campaign from the sea. The Gerald R. Ford class ensures that this capability remains an American monopoly, enforced through technological and industrial superiority. It is a weapon of system-level logic, designed to function within a network that sees everything and can strike anything. The $13 billion cost is a testament to the fact that in the realm of global power, there is no substitute for physical displacement and energy output. The Gerald R. Ford class aircraft carrier, a floating nation, a nuclear-powered fortress, and the ultimate instrument of global power. As we move into an uncertain future, this 100,000-ton Titan will remain the definitive symbol of maritime dominance and technological apex.